Hey there, welcome to the Guided Practice 25. This is on our section 11.6, our ratio and root tests. Okay, so keep in mind if we're thinking ratio and root test I'm only going to use if I have everything to the nth power. Otherwise, I'm going to use ratio test. So when I look at number 1, when I've got n factorial over 5 to the n, the n factorial is not to the nth power, so I'm going to use ratio test here. Which means I'm going to look at the limit as n goes to infinity of absolute value of the ratio. So in the top, I replace my n with n plus 1. So this is n plus 1 factorial over 5 to the n plus 1. On the bottom part of the fraction, I keep the original, n factorial over 5 to the n. So the first thing I'm going to do is flip this. Flip the bottom one up. So this is n plus 1 factorial over 5 to the n plus 1 times 5 to the n over n factorial. Next, I'm going to split off the n plus 1 away from the rest of it for that first term. So n plus 1 factorial is n plus 1 times n factorial. And on the bottom, 5 to the n plus 1 is 5 times 5 to the n. And I'm multiplying that by 5 to the n over n factorial. That way, my 5 to the n's cancel, my n factorial cancels, and I'm looking at the limit as n goes to infinity of n plus 1 over 5. When you plug in your infinity, you get infinity, which means this is greater than 1, so this is divergent by the ratio test. Number 2. Again, I have 2 to the n on the top, but the bottom one does not have an n power, so I'm not going to use the root test. I'm going to go ratio test here again. So we're going to look at the limit as n goes to infinity, absolute value, 2 to the n plus 1 over n plus 1 to the 4th, all over 2 to the n over n to the 4th. Again, first thing we do is flip that. So we're going to have 2 to the n plus 1 over n plus 1 to the 4th times n to the 4th over 2 to the n. From there, we're going to split up our first term so that we don't have n plus 1. So that's 2 to the n times 2 over n plus 1 to the 4th. This is a big one, so let's see. If I multiply this out, we're going to have n plus 1 cubed. I know what that one is. That one's n cubed plus 3n squared plus 3n plus 1. I've got to multiply all of that by n plus 1. Little side scratch work here. All right, so if we take all of that times n, that's going to give me n to the 4th plus 3n cubed plus 3n squared plus n. And if you multiply all that by 1, you get n cubed plus 3n squared plus 3n plus 1. So when you add that together, you get n to the 4th plus 4n cubed plus 6n squared plus 4n plus 1. That's what goes underneath here. So this is n to the 4th plus 4n cubed plus 6n squared plus 4n plus 1. And then I have n to the 4th over 2 to the n. Let me look at what cancels. The 2 to the n cancels, and I can pull the 2 out front, or I can leave it. Let's leave it. Let's make it the limit as n goes to infinity of 2n to the 4th over n to the 4th plus 4n cubed, 6n squared plus 4n plus 1. And when you take that limit, you have 2 polynomials, both of which have degree 4. So the limit is the coefficient of the leading term. So that's 2 over 1 equals 2. And that's greater than 1, which makes this divergent by the ratio test. Okay. So those two are ratio test. Number 3 is going to be the root test. Okay. Okay, now when I look at these and I see the -1 to something, I'm not going to worry about that because when we take the absolute value, we're going to lose our -1s. So really I'm just working with this bottom piece, which is ln n to the n. So I want the root test here. So we want the limit as n goes to infinity of absolute value of this thing, -1 to the n minus 1, all over the natural log of n to the n, and we're going to raise that to the 1 over n power. When I simplify this, the absolute value is going to take care of our negatives. So we're going to have 1 over the natural log of n to the n to the 1 over n power. And then these two cancel out. So when you multiply those, that becomes 1. So this is the limit as n goes to infinity of 1 over ln of n, the absolute value of that. And when you take n to be infinity, this is 1 over infinity, which is 0. This is less than 1. Therefore, this is convergent, absolutely convergent. By the root test.